Ted to join us today. We're trying to get our network of healthcare folks more involved in the consultant networks here. So Ted, with that, the stage is yours.
Well, Mike, good morning to everyone, and thank you very much to you as well as the IEEE Seattle chapter, the electrical consultants and engineers. I am privileged to be a part of your talks today. I really have enjoyed the previous speakers, learning a lot, and really actually connecting some of what has been said prior to today's talk. And today's talk is something that may be interesting to everyone on this call. It probably is, given where we are with regards to the global pandemic, and it's about healthcare. Healthcare delivery, as we all know it, the physician practices, hospital networks, acute care, trauma, et cetera, as well as the insurance side, is actually a larger domain, right? So if you have to include, and most folks are kind of become much more familiar with this these days, the pharmaceutical side of things, the bio and life sciences side of healthcare, where drug discovery and efficacies and other chemical interactions and other bio devices can help to improve care and wellness delivery. So if you think about that entire scope, use that lens, if you will, during my talk today. And we're going to go quickly and lightly over some pretty deep subjects, but effectively, if you can observe the screen on the left side, you'll see obviously a depiction, if you will, of today's service delivery model, right? And you got the cloud in the middle. So, of course, a lot of the enterprises in all industries are moving more towards, cloud services for compute, network, and data storage, et cetera, those kind of services. However, if you think about the actual behind the scenes, the enterprises, still operate in a very centrally, controlled, static environment. And this has resulted over the years of evolution in healthcare of siloed data repositories, siloed interactions, et cetera. And if you think about healthcare, it's really a team sport. You've got a primary care physician. If you have a need, you've got, specialty care. God forbid you have a trauma or an accident, you've got to have those kind of things taken care of at the acute care facility. You got outpatient, you got lab, you got radiology, et cetera. So there's a lot of players that, need to come together in order for you to get care as a human, right? And for society to get personalized care, we think it has to go to the next level. Now, the right side of the diagram sort of depicts at a very high level a decentralized, distributed model, right? And where most other industries are moving today. You think about Amazon, right? It's an online retailer, and they really don't sell anything themselves, but they actually allow you to get to everybody, if you will, that sells stuff, right? So we think about healthcare in the same model, and all of the players that I just described. It's important that there's some sort of decentralization and the removal of intermediaries, because oftentimes, as you guys would know, speed to care, it oftentimes means, in healthcare, life or death, and that's not a overuse of the cliche. Now, what's happening is this: some of the challenges to move from, if you will, left to right, are growing, right? So, for example, think of the data that are created today at enterprises on the left-hand side and so on, and that data is growing, right? The data are growing because, technology to store and persist data, have improved. The lots of use of applications, and especially over the last decade or 12 years or so, where the regulations at the federal level and at the state and local government level have increased the use of health information technology. So data are increasing at the enterprise level, but also think about what's happening on the technology side, right? As our prior speaker, Raghu, has just mentioned, right? The advancement of networks, the high bandwidth, low latency or high speed, if you will, networks is really opening up the use of, devices and so on. And of course, the advent of the smartphone provides a platform for the compute elements. And now you have the increases of data, right? And so data challenges exist. And we also think because of that, the trust that those data can be transferred and treated properly in a secure manner, but also allow for a contextual conversation for me and my clinical practitioner those challenges today exist. So what we're doing is we've exposed the thesis, and we have a postulate that says there's an interrelationship between three elements of data management, right? And you could read them for yourselves and so on. But I've put on the screen here a simple model for suggesting how data turn into artificial intelligence or augmented decision support, right? You have to ingest from disparate sources, which have various vocabularies. You have to curate what's important, strip out the noise, and so on. Express the data in a format that's favorable for modeling and machine learning, and of course exercise artificial intelligence, which are effectively algorithms that are executing against patterns that are predefined and so on. And we see healthcare today, developing within enterprises and across ecosystems. A lot of great examples of progress here, where interoperable data pipelines that perform the functions I just mentioned, are being stood up, and improvements are being made to enable integration and interoperability, certainly in access and use. Who hasn't had a telehealth interaction in the last year? Probably most of us. And building trust and value, right? And we're going to express a premise here that trust equals value, because if you're basically looking for operating efficiencies and you're seeking to modernize your compute and processing capability as a healthcare provider, you want to also differentiate yourself to be able to stream and use data as an asset, right? And that allows you to move towards interactive modalities, or as I just referred to as virtual care, right? So our postulate is basic, right? It says in healthcare, and this may apply to other industries as well, you guys might be a better judge of this, but in healthcare, trust equals value on a linear relationship. That means that the more trust you can build, right, with regards to accuracy, with regards to security, with regards to context and personal, use in the moment, right, timely, you can actually deliver more value. Now, certainly, there's many variants of these words: trust equal value. And we're working with several organizations, and I'm going to go into that in a second to help us to understand this better. But if you think about the clinical practitioner, he or she needs to be sure that the data are accurate. The information that's being used, whether it be from an electronic health record or some source of determinant of health, like a lifestyle choice that you may have made, like smoking, or et cetera, or BMI index, and so things that are being used today. Right, the practitioner needs to understand and be sure that that's in context, it's accurate, and it is as up to date as possible. And that's difficult today in the enterprise. But think about that decentralized model that we're professing and expecting things to migrate towards very rapidly, right? So in the moment versus longitudinally deduced means, you really want to have the physician practitioner or the clinical practitioner, if you will, have the information about you, not to a generalized population, right? Because you have different genetics, you have different vigilance with regards to how your biology in your human makeup, how they perform and so on, and you react differently to certain drugs and so on. Many folks are reporting just a soreness after getting a COVID-19 vaccine. Others are coming down with symptoms that range from tiredness and fever and so on, but all the way to some bad things that we won't go into today. Now, the variance of value also move towards, of course, there's a monetary use. And there's a lot of organizations out there in healthcare that are trying to monetize the use of our data. Our data means the patient, right? It really should be ours, but there are organizations that are growing, and they're thriving, and they're actually doing quite well with regards to giving back to the industry, regards to analytics and so on. But we really want to have a situation where we create an environment where we have a self-sovereign ability to control our own data, right? And that's that trust factor. So at Symbotics, we've embarked on an element collaboratively pursuing the development of industry utility, right? And that utility is going to supervise a standard protocol for data encoding and decoding, as well as execution of logic, right? The actual computer programming. So if we have a standard protocol, we could streamline that pipeline that I shared with you earlier, right? All those elements that are across the pipeline, and that was oversimplified for sure. And if we streamline that and simplify it for the industry, right, we think we can make rapid strides and much more, quickly move towards the model on a decentralized, personalized, precision-based care. Precision-based care means it's about me, It's about my interaction genetically with pharmaceuticals. It's about my interaction vigilance-wise due to my physiology and my biology with regards to exercise or not, or smoking or not, and so on and so forth. Everybody has unique responses. So we've embarked on building an operating system at the health industry level across all of the elements we described earlier, where this standard protocol can operate from enterprise all the way out to the edge, out to the devices that Mr. Raghu was referring to, again, that are attached to high-speed networks today that can provide capacity and allow for reach to occur from practitioners all around the world to an individual like myself here in Raleigh, North Carolina. We're reaching out to big tech organizations. Obviously a lot of the names that you would recognize in big tech, IBM, Microsoft, Amazon, et cetera, the players there. NVIDIA, who are actually moving forward with high performance compute on small devices, and the list goes on. Industry players, a lot of the provider networks, there are a lot of consortiums that are forming that include providers and insurers and so on, and we're including them in this project. And certainly from a science, academia, and movements perspective, what I mean by movements is the Linux Foundation and the Partnership for Digital Health Institute. There's a number of organizations that are standing up now to advance collaborations. Also from a science and academia perspective, we collaborate strongly with MIT Media Lab and the data connections and the data trust initiatives that they are having underway now. The project is a Linux Foundation licensed event and project there. It's an open source code. You can go out and get the code if you want. And there's the address for any that are interested. We're building an operating system. Won't go into a lot of details here, but there's 3 tenets, if you will. Certainly that serve as supervisors we talked about, and the abstraction of technology, because we think adoption of new technologies like blockchain really will be accelerated if we abstract the complexities of such. And the operating system supervisor can do that and offer computational governance in a trusted manner, right? In other words, people can actually execute at the edge smart contracts and get things done over a trusted protocol where identity is maintained. And that's where we go into the actual trust element regarding identity. Of course, eventually we think there will be a new incentive model. It's all emerging. It's probably a little bit off in the future, but we think by accelerating some of the fundamental obstacles, we can move more towards arbitrage of fungible and non-fungible assets that are called tokens these days. And again, that runs across a blockchain. A quick picture, if you will, of what we have with regards to interoperability on Linux for Health. And again, this is the kind of capabilities, and we mentioned a number of things in here with regards to application program interfaces and other translation devices that allow various disparate systems to connect into each other. And these elements are already inherent in our operating system that the service supervisor would utilize for smart routing, for capturing of longitudinal events, understanding the patterns within those events, and enabling machine learning AI engines to act on those events as the patterns arise, and the algorithms become smarter, recognizing previous patterns. Now, as we start to talk about the abstraction of health standards and the modularity of things, the mobility of things is really going to continue to increase. And I have at the bottom of this integration chart here a set of chip architectures, and it's becoming more and more important to operate on a small device, even something that's referred to as a Raspberry Pi, which is a very small device that has pretty decent compute power. I've been in the industry a long time, and some of these things are as size as your fingernail. And when I started out in the industry, there were rooms full of compute, machinery sizes of refrigerators are larger, right? So now it's becoming much more small, compact, and fast, and we're actually trying to help the industry move forward and take advantage of all of these advances in compute and in the use of algorithmic mathematics for computational governance, for execution of smart contracts, et cetera. Now, if we take a step back, Symbotics here is moving forward and espousing a model, if you will, that's what we call the community cloud ecosystem. So if you think about all of the players within a community, not just the healthcare providers and the clinical practitioners, labs, radiology, and other ancillary organizations, really talking about a community like small businesses, large businesses, state and local Department of Health and Human Services, consumers and patients. You think about your community today, and you probably become a lot more familiar with them because your travel may have been limited over the last 13 or 14 months and so on. It becomes important for us to be able to tighten the aperture of data sets around your specific community in a geographical spatial manner. In other words, whether it's at a neighborhood, whether it's at a town or a city, whether it's at a state, right? We think by tightening those apertures, connecting into and advancing movements like the smart city movement, and a lot of folks are probably aware, again through some of the 5G capabilities that are moving forward, the advancement of technology is moving forward to making cities much smarter. Retailers and other organizations today are using things like hyperlocal, which is an observation technique to manage, to understand where population and people are moving, and they're actually using that for incenting consumer behavior. Now, we think a better use of that would be for us to understand population movements with regards to a pandemic, and understanding where efficacies are positive and where they're not, and actually get the real data in real time. So we're moving forward with this. I'm not going to go into this detail here. This is a quick, simple 3x3 with cost, quality, experience, dissecting across the three areas that we're using in our postulate, that being integration, access, and trust equals value, right? Focusing down at the bottom here, understanding that with a self-sovereign identity, individuals are, first of all, they're anonymous, right? So no one can steal your identity. And then you're also allowed via the technology called blockchain to provide consent and or permission to, one, access your data or not, or to modify your data or not. And think about that to protect yourselves from theft, fraud, and all those other activities. But in the healthcare space, keeping your personal health information secure would probably induce additional adoption of telemedicine, both from the practitioner's perspective as well as with regards to the actual consumer themselves being much more comfortable with it. We've come across a company, we're working extensively with a company by the name of Devio, and they've come up with some very unique blockchain technology that takes advantage of sharding, which allows a higher granularity. Of most of the blockchain implementations today tend to run into problems with scale, or if they try to fix scale, it drives a lot of cost. This organization today, so we're doing a call out to Devio here today because they've got some unique stuff that can really advance the game, we think, towards really spinning up information that's contextual, personalized, and relevant in the moment. Now, think about a telehealth episode happening with an individual looking at his or her phone, and the practitioner has access to a history of when you are healthy, so they can understand the differences because you might be experiencing illness. What was the last visit that you had with a practitioner? How about your lifestyle choices and so on? Well, you run every day, you take advantage of it, right? So they know your heart rates, your respiratory, and so on. And all this stuff can be indexed for search. So if you think about the practitioner simply having a rectangle box, a la what consumers use today called Google, and just entering, why is Ted Delavecchia having a headache, right? And all the information can come together in a pattern and sort of direct in a personalized and a precision manner the practitioner to actually make the right prescriptive diagnosis and treatment plan. So kind of ran across a lot of topics here, a lot of deep things. You might sense I'm a bit passionate about this, taking my entire career now focusing on advancing this game. We see healthcare has evolved as a data problem, which we think we can solve simply through utilizing a standard protocol that is delivered via trust over technologies like blockchain. And we think that once that trust element, once that self-sovereign identity is cracked, it's allowed to be prevalent. People are comfortable with having their health information shared with anybody because it can be managed, again, in an individual and anonymous way. That they can't identify Ted Delavecchia lives at XYZ Street in XYZ town, right? They just know that I'm a patient, XYZ, and then they can treat me. So now I'm much more comfortable to allow intervention in my home over a device or wherever it might be more convenient to me, instead of me having to go to the monolithic traditional, that's my little timer there. So the traditional methods of care delivery. Again, went pretty quick over a lot of topics. I don't know if there were any questions, and if I have time, Mike, and you'll be the judge of that.
Paul,
Actually,
you got a question? Go
Yeah,
ahead.
Ted, I do have a question for you. So you've talked a lot about the technology involved. What about the energy involved? Will this blockchain application for healthcare require high amounts of computing power and resulting energy, like Bitcoin? Or will one or two institutions or your own healthcare institution handle the transactions and add them to the blockchain? And what visibility will there be?
Yeah, excellent question, and you're right. Bitcoin is actually anti-ESG, environmental, social, and governance, and the concern is such as that grows, it chews up more and more, and creates much more carbon emissions. So it's a very good question. No, the blockchain technology we're talking about is 1/1,000,000th of a cost, if you will, and that's not an over-exaggeration of something like a Bitcoin, which runs in general like an Ethereum application. And it can operate on low compute power devices.
Let's have a really quick question. You mentioned AI. Blockchain, are these, whatever you got going, do they learn? I mean, AI means learning, right? So from all the data. Can you address that real quick?
No, excellent question, Mike. So I expressed on that one of the last diagrams, a bunch of little webs on the page there. Those were really knowledge graphs. And if you express your data in a knowledge graph and you train your machine learning engines in that manner, it actually accelerates the adoption and the creation of much more, pattern recognition capabilities. And then you can execute your model responses through your AI mechanisms in that manner. Pretty simply. So again, it's not a technology problem. We have the technology available today. It's really the adoption. And we think the element is getting that digital identity taken care of and having an operating system handle the standards with regards to, encoding and decoding of data.
Okay, we appreciate it, Ted. I'll let you go.
Thank you very much for having me, Mike and team. It's been a great pleasure. And again, my email is on there. Please don't hesitate to contact me if necessary.